The assignment that is due today is 3.7. Today, the main idea is trig review and the derivatives of trig functions. Trig review and the derivatives of trig functions. That's awesome. All right. In this class, you will never see me write something like this. Why not? It's a degree. In this class, it's all going to be for our sine and cosine, our trigonometric functions, it'll always be radians. So instead of sine of 60 degrees, I would write what? What's the equivalent to 60 degrees in radians? What is equivalent to 60 degrees in radians? Sasha, what's equivalent to 60 degrees in radians? It's, yeah, this is going to be pi 6. It's going to be pi 6. Yep. All right. So what if I wanted, this is, because pi 6 is one of our special angles, this is something that we're going to have to do. This could be a non-calculator based question. So how would I figure out what sine of pi 6, what that is? Hey, Ava. Avadil. I could actually draw this out if I wanted to and say that this is our, you know, this would be our, what, 30, 60, 90 degree angle. And the relationship between the, well, if this is a unit circle, my hypotenuse is 1. And then the relationship between the shortest side and the longest side is always that the shortest side is half of that. So just from our understanding of a 30, 60, 90 triangle, we could figure out that the answer for this is going to be 1/2. Right, opposite from our angle, opposite over hypotenuse, that's the definition of sine, would give us 1/2. But we can also use the hand trick. In fact, that's what I would encourage you to use in this case. So the question is, do you remember the hand trick? It's not a bad hand. And let's say that, well, this is going to be our first quadrant right here. And we always start at our initial side. Our initial side is the positive x-axis. That will be a rotation of 0 degrees, followed by what? What would that be? What's this rotation here? Yeah, that's going to be our 30. That will be 30 or pi 6. What about this one? Yeah, that's going to be our pi 4ths. And this one here. Yeah, it's going to be pi 3rds. I think I ran out of room there, pi 3rds. And this one here. Pi halves, yeah. Pi halves. Now, on the palm of our hand, we are going to draw a square root of x over 2. And if we're trying to figure out a sine function, we go from the pinky. And if we try to figure out a cosine function, we're going to go from the thumb. So we could also, if we wanted to recreate the same thing using the hand trick of sine of pi 6, we put down the pi 6th finger. How many fingers do we have up from the sine direction? 1. What do we do with that 1? Yeah, that gives us the square root of 1, which is 1/2. It gives us our 1/2. Cool. Right, what if I'm trying to find cosine of pi 4ths? How do I find cosine of pi 4ths? Louder, please. Miguel?
Oh, it wasn't me talking.
Okay. Sam? Okay. Sam, do you know how to calculate, find cosine of pi fourths without a calculator? Yeah, so we're going to go from the cosine direction, from the thumb direction, but what finger do I put down? Yeah, we put down this middle finger. When we put down this middle finger, how many fingers do we have up from the sine direction, the cosine direction? 2. What do we do with the 2? We plug it into our formula here. That gives us what? It gives us, we plug in, so again, we're going to put down this finger here because we're trying to find cosine of pi fourths. We have 2 fingers up, we're going to plug that into here. So that gives us, yeah, so 1/2 times the square root of 2, is that what you said? Or just the square root of 2 over 2. So that gives us the square root of 2 over 2. Okay, let's do another one. What if I'm trying to find cosine of pi 6? Nice. Square root of 3 over 2. I'm going to put this finger down right here. That why? Because that's my angle. We're trying to figure out what cosine of pi 6 is. So we count from the cosine direction, from the thumb direction. I have 3 fingers up. Plug that into our formula here, the square root of 3 over 2. That gives us our answer. All right, what about if I'm trying to find sine? What if I'm trying to find sine of pi thirds? Yeah, I'm going to put this finger down right here from the sine direction. I have 3 fingers up. I'm going to plug that into my formula, the square root of 3 over 2. Nice. Square root of 3 over 2. Now, what if we get something like this where I have the I have cosine of 2 pi thirds? What quadrant am I in? I'm in the second quadrant, right? Because this is a half circle is pi. I'm going to divide the half based upon this fraction. How many units am I going to divide this pi up into? Into 3, right? So I'm going to divide it up into 3. So 1, 2, 3. Now, how many of those units do I traverse through with my rotation? 2. We always start at the initial side. We always start here. And it's a positive angle. So I'm going to rotate 1, 2. That puts us in the second quadrant. Now, what's really cool though, is that this triangle over here is congruent to this triangle here, meaning that this y value over here is that same length is here, and that this x value over here, this length here, is the same as this length here, right here. So we can use this idea over here. We can just use our hand trick to figure out this rotation here, which is pi thirds. So to figure out cosine of 2 pi thirds, I can figure out first cosine of pi thirds, which is what? Of pi thirds. So yeah, it's going to be 1/2. That's going to give me 1/2. I have 1 finger up, so I'm going to put that into my formula. Square root of 1, which is 1, 1/2. So this is 1/2. But how is this point here different than this point here? Or are they the same? Yeah, your x value is negative. I'm going to the left. So the x value is negative. So the answer to this would be negative. So that's my answer right there. Let's do another one. I have sine of 7 pi fourths. What quadrant are we in? What quadrant does that put us in? The fourth quadrant, okay? So we're going to divide up pi. This is half circle rotation is pi. We're going to divide that up into units of 4. So that gives me 1, 2, 3, 4. We'll do the same thing down here. And we always start at our initial side, and we're going to rotate clockwise or counterclockwise? Counterclockwise. When do I rotate clockwise? If it's a negative angle. Right now, it's not a negative angle, it's a positive angle. So I'm going to rotate clockwise. So I have 1 pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths, 5 pi fourths, 6 pi fourths, 7 pi fourths. Now, what's really cool is that this triangle right here is congruent to this triangle here, meaning that I can find out this point right here for my X and my Y value, except, or just by figuring out what this rotation here is. So for that rotation there, what do I get using my hand trick? Louder? Yeah, I get the square root of 2 over 2. I get the square root of 2 over 2 for that rotation there using our hand trick. We just put down this finger right here. That gives us, I have 2 fingers here, the square root of 2 over 2. And so I have the square root of 2 over 2. But how is this length here different than this length here? Yeah, one of them is negative. So we make this one here is negative. So for this rotation here, that has to be negative. Do we need to talk about why? Let me write this out. Do we need to talk, if right now we're doing a really important comprehensive review of trigonometry, do we need to talk about why sine of theta is equal to y and cosine of theta is equal to x? Would anybody benefit if I do a review of that really quick? Do you want it or not? Everybody good? Yeah. Let's review it. Okay, for a unit circle is centered at the origin with a radius of what? Of 1. Radius of 1. That's what a unit circle is, as 1 unit, a radius of 1. Now, if we, for the unit circle, any point along the circle has an x followed by a corresponding y value, which means the way that we understand a coordinates, the x is our left-right movement followed by our up-down movement. So we have from the origin, we move over to the right, x units, and then we go up y units. Now we can also describe for this unit circle, we can also talk about the point in terms of rotations. Let's call this theta. This is theta. That is theta. So in terms of theta, well, let's look at what sine of theta. Oh my word. Let's do cosine. Cosine of theta. By definition, cosine of theta is what? It's a ratio. What is the ratio? Yeah, it's adjacent over hypotenuse. From this perspective right here, what is adjacent over hypotenuse? Yeah, this is x over 1, which is just x. So for the unit circle, cosine of theta equals x. Now, if it wasn't a unit circle, it was, I don't know, maybe a radius of 10. This is a radius of 10. Then all we do is my x then is going to be 10 times cosine of theta. That point right here is my x value right here would be just 10 times cosine of theta if my radius here was 10. But this is a unit circle, so it's just 1 cosine of theta. All right, let's look at cosine, sine. By definition, the ratio of sine of theta is what? Opposite over hypotenuse. From this perspective here of theta, What is opposite over hypotenuse? Y over 1, which is y. So what we learned from this is that sine of theta for a unit circle is our y value, and cosine of theta for a unit circle is the x value. So we're literally talking about, when we're using the hand trick, we're literally talking about points along the unit circle. So let's do it. Let's do another one. What if I have, I'm going too fast, let me know. I want to find sine of 4 pi thirds. Kyle, are you paying attention? Awesome. Kyle, what quadrant am I in? Kyle, what quadrant do I rotate into? Where's my terminal side? Yeah, it's the third. Yeah, we're dividing up pi into units of 3. So here, 1, 2, 3. And it looks like we're going one more. So we're looking at a rotation of, here's 1 pi thirds, 2 pi thirds, 3 pi thirds. Well, 3 pi thirds is just pi. That's what we know a half circle is anyway. And so one more gives us 4 pi thirds. But what's really, really cool is that this triangle here is congruent to this triangle here, which means our sine, is that our x or our y value? Our y value, that this length here is the same as this length here, except this length here is what? Negative. Yep. So let's figure out what this rotation here is. What's this rotation here? Isn't that just pi thirds? Isn't the rotation pi thirds? Okay, the rotation is pi thirds. All right, what is the y value here? What's the y value? Yeah, this is going to be the square root of 3 over 2, which means then that this point right here, our y value is what? Yeah, negative the square root of 3 over 2. So that's my answer. Negative the square root of 3 over 2. That's my answer. That is the answer. Andrew, you okay? Andrew, are you all right? Oh, yeah. Okay, awesome. Okay, the only concern that I have is, what if we're in between quadrants? What if I have something like this? I have sine of pi halves, or cosine of pi, or sine of 3 pi halves. Let's do cosine. Cosine of pi. Let's do cosine of 3 pi halves as well. What if I'm in between quadrants? I would argue that the hand trick sort of fails us when we're in between quadrants. So there's an easier way to think of being in between quadrants. And that is just use the unit circle. Just use the unit circle. So here's my unit circle. Let's just grab a circle like that. And what, for our unit circle, what is this coordinates right here? What is it? Louder. 1, 0. What's this one right here? 0, 1. What's this one here? Negative 1, 0. And this one here? 0, negative 1. And so if I want to figure out what sine of pi halves is, what is it? It's 1, yeah. We're rotating, this is a half circle here, pi. So half of a pi would be this rotation to here. And we see that sine, that's our y value, is 1. What about cosine of pi? Yeah, that's a half circle rotation. That would bring us to here. Cosine is our x value, and so our x value here is -1. So the answer is -1. What about sine of 3 pi halves? How far do I rotate? I'm rotating. Here's 1 pi halves, 2 pi halves, 3 pi halves right here. It's -1. Yeah, sine is the y value, and the y value here is -1. Yep. So -1. What about this one? Yeah, it's 0. Cosine is my x value, and my x value after rotating 3 pi halves is 0. So that would give me 0. Half of your test for your AP test, half of your test is without a calculator. You do need to know this. So how would you get extra practice if you are still confused about this? A good way of getting extra practice would be to, actually I have a whole, there's a whole test that I have that goes through all of these. And another way, I guess, is, I wonder if we could find something like practice test on trig ratios with radians. Just curious to know if there's something there like Quizlet or something that would give us some extra repetition if we needed it. Here's Khan Academy, radians and degrees, SAT, Trig, SOHCAHTOA. Here's a practice test. I wonder whether that is something that would be even helpful. But there are ways of getting the extra repetition that we might need. In fact, I wonder if I scroll down to the bottom here. Oh, it gives us all of the answers. Gives us all the answers down here at the bottom. So what you could do is you could go to this and try to do some of these problems. 144 degrees, what is that in radians? That's less important. What I really want to do is figure out my sine, problems like this. Sine of, that's a code function. Like this one here, cosine of 5 pi 12ths. I think they used a calculator with that one. Use a calculator, yeah. Here's cotangent. In fact, speaking of, here's some other problems here, but here's 16 pi thirds. Wow, that's rotating several times around. So down here at the bottom of the test, that stuff would be more helpful. But I do have a test on, or a quiz. I have a quiz that will cover all of the different possibilities. So I think there's something like 20 different questions. So what if you're given something like tangent? What if you're given something like, let me use black. Tangent of the square root of 3. Or tangent of, I'm sorry, I messed up. Tangent of pi fourths. I was using the wrong units. Or tangent of pi sixths. Well, I don't really have a tangent finger. So how would you do this? We need to remember one of our trig identities. What is our trig identity that would be helpful here? Yeah, sine of pi fourths over cosine of pi fourths. Okay. Using the hand trick, what is sine of pi fourths? What's the, I'm sorry, what is it? All right, it's square root of 2 over 2, nice. We have the square root of 2 over 2 over what's cosine of pi fourths? So what is the square root of 2 over 2 over the square root of 2 over 2? It's 1. The answer is 1. What about this one? Same thing. We have this, in this case, we have sine of pi sixth over cosine of pi sixth. Well, what's sine of pi sixth? Louder, please. Yeah, it's 1/2 over square root of 3 over 2. What's the rule? When we divide by fractions, here's a tip. Keep, change, flip. These cross out, and we're left with the square root of 1 over. We're left with 1 over the square root of 3. Now, I want to remind you that when it comes to free response on the AP test, just stop there. Just say that's your answer. The only problem I have is that that might not be an answer from multiple choice because in the United States, a square root in the denominator is not considered simplified. So for a free response, stop there. You're good. That is your answer. But for multiple choice, you might have to take this one step further. How would I simplify this so that I don't have a square root in the denominator? Multiply by 1 in the form of the square root of 3 over the square root of 3. That gives us the square root of 3 over 3. Yep. There we go. That's the answer. Andrew, you have a question? Did you have a question?
Oh, no.
Does Emerson have a question?
Nope.
Okay. Let's move on then. If I'm going too fast, let me know. There's a couple of identities. Speaking of identities, there's a couple of identities that I do expect you to have memorized. Identities you need to know. So trig, identities. You need to know. Now, if you want to make flashcards out of these, that would be great. Maybe some of you already know these. One of them is that tangent of theta equals what? Sine of theta over cosine of theta. Another trig function is the Pythagorean identity. Do you remember the Pythagorean identity? Sine squared plus equals 1. Yep. That is something you have to have memorized for the test. All right. Another one is all of your reciprocal identities. The reciprocal identities would be, for example, secant of theta. What is secant of theta? Anybody remember this? The reciprocal identities? It's 1 over what? 1 over sine of theta. Now, one thing I want you to remember when it comes to the reciprocal identities is that the letter that the reciprocal identity is will never be the same. It's cosine. Yeah, this one is cosine. What about secant? Secant of theta? 1 over? Yeah, the 1 over sine of theta. And then we also have cotangent of theta. 1 over tangent, yeah, 1 over tangent of theta. Which means then that we also have, this is called our quotient identity right here. We also have a quotient identity for cotangent. Any guesses what cotangent of theta is? Cosine of theta over sine of theta, yeah. Yep. So that's basically it. Those are all the identities you have to have memorized. I don't think that's too bad. Is everybody good? Okay, let's do, I want to simplify. Simplify. And I have cosine of the inverse of sine of 1 over the square root of 2. How do I simplify this? Well, what's this piece here? Is this a special angle? What is 1 over the square root of 2? It's not simplified because the square root of 2 is in the denominator. So I'm going to multiply by what? Yeah, the square root of 2 or the square root of 2. So that gives me the square root of 2 over 2, which means that it is one of our special angles. So this is the same thing. This piece here is the same thing as saying sine of theta equals the square root of 2 over 2. I'm trying to find what? What is this? What kind of measurement is this? It's an angle. I'm trying to find an angle. What is the angle? Yeah, it's pi fourths. So if all of this is pi fourths, then I now have cosine of pi fourths, which is what? Yeah, this gives us the answer to this is the square root of 2 over 2. That's my answer. Questions? Is everybody caught up? How you doing, Emerson? Awesome. Good to hear. Eleanor, are you caught up? Okay, let me scroll to the top then. All right, same thing. I want to simplify, same directions. I want to simplify. This is B. We have secant of the inverse of tangent of 1 over the square root of 3. What is this piece right here? Sure, you could do it that way. The only problem is I have, I don't like that I have one, actually, I'm gonna leave that, that's fine. And so you wanna rewrite this as, okay, so you wanna rewrite this as the inverse. I haven't thought of doing it this way before. That's sort of interesting. If I wanna do it this way, I should probably, well, I don't know if you can actually do it that way. let's consider this. There is one finger that I have to put down, right? And we do know that sine of theta over cosine of theta is going to give us our tangent of theta. Now, this is really tangent of theta equals 1 over the square root of 3. So I want to know which of these fingers I'm going to put down. This is 0, pi 6, pi fourths, pi thirds, and pi halves. In the palm of my hand, I have the square root of x over 2. And from the pinky direction, that's my sine. And from the thumb direction, that's my cosine. And I'm going to have to put a finger down to recreate this 1 over the square root of 3. Now, the question is, what finger? There's not a lot of choices. In fact, there's only 2 choices. We can rule everything out except for 2. Because I have a square root in here of 3, that means there's only 2 possibilities. What are there? What are they? It's either pi 6 or pi thirds. There's no other option. Now, there might be an easier way to do this, but what I do is I just guess. I just pick one. Pick one, anyone. If it works, great. If it doesn't, then it has to be the other one. Which one do you want to try? 6. Let's try pi 6. So if I have sine of pi 6 over cosine of pi 6, then sine of pi 6 is what? We put this finger down. That's going to give us 1/2. And cosine of pi 6? When we divide by fractions, here's a tip. It's 1/2 times 2 over the square root of 3. These cancel out, and that's in fact what I get. So the angle has to be what? Actually, all of this is what? It's pi 6. Yeah, it's pi 6. So now I have secant of pi 6. So I have secant. What this gives me then is that I have now secant of pi 6.
I'm a little confused.
What are you confused about?
So this is tangent, this is inverse tangent, right?
Yeah.
So wouldn't that mean that it's actually cosine of pi 6 over sine of pi 6?
So this is tangent, not cotangent. So
But isn't cotangent, isn't like, where if you could, this could also mean 1 over tangent of it.
this, so the way that an inverse, so this isn't, so I think you're mixing up tangent and cotangent.
Okay.
So tangent, let's see. So tangent is sine of theta over cosine of theta, and cotangent is cosine of theta over sine of theta. Now neither of these are inverses.
No.
So what is an inverse? Well, an inverse is, let's consider if I have y equals sine of theta. Isn't that a graph that looks more or less something like this? Okay. Now the inverse is always going to be a reflection across the y equals x. So the inverse of this is going to look something like this, which isn't a function. So we can only use the values from -1. Can only use the values from -1 to 1, this piece here. Because of sine of theta is opposite over hypotenuse, and the hypotenuse is the longest side, then the range is from -1 to 1, and the inverse of that becomes the domain from -1 to 1. So we only have a piece of that. So if I graph that, in fact, let's just graph this really quick. If I graph, so we have www.desmos. And I have y equals sine of x, looks like this. And the inverse of that is y equals, here's the inverse, inverse of x, looks like that. is just a little piece. Why is it only a little piece? Yeah, otherwise if it just kept on oscillating, it wouldn't be a function.
So wouldn't
It's
that be the same as saying 1 over sine of x?
1 over, is this the same as 1 over sine of x?
Yes.
No. So let's cosecant, oops, cosecant of x is equal to 1 over sine of x.
Okay.
But we're talking about inverses, which is a different idea. These are just reciprocals,
Okay.
whereas this is an inverse. Okay.
So what makes tangent, inverse of tangent, be the same as tangent?
Why does
in the value that we get?
Why does the, I guess I misunderstood. Why does let me get rid of all this.
Same as frequency,
So the reason why we have an inverse is normally if I have something like x plus 5 equals 10, the inverse is negative, right? Because that allows me to undo a function. Now, if I have something like sine of theta equals, I don't know, the square root of 2 over 2, then to do an inverse, it allows me to isolate my variable. Just like over here, it allowed me to isolate the variable by doing inverses. So if I do an inverse, typically, when I do an inverse like this, these go away, leaving me with theta equals the inverse of sine of the square root of 2 over 2. What am I trying to find with this? I'm trying to find an angle. In fact, sine of 45 degrees equals sine of 45 degrees, sine of 45 degrees, actually 45 degrees equals that. 45 degrees equals this because that's our inverse. Okay. So let's do another one. Did we even finish that one? I don't think we finished that one. So I'm trying to figure out secant of pi 6. What is secant of pi 6? Secant of pi 6 is the same thing as what? 1 over cosine of pi 6. What's cosine of pi 6? If I put this finger down here, it's the square root of 3 over 2. Now I'd be cautious about what that 1 means. That 1 really means 1 over 1, right? So we have, when we divide by fractions, here's a tip. You have 1 over 1 times 2 over the square root of 3, which gives me 2 over the square root of 3. There we go. That's our answer. That's what this becomes, is 2 over the square root of 3. Only thing I don't like is that I have a square root in the denominator, but you can certainly fix that by multiplying by 1 in the form of the square root of 3 over the square root of 3. But if it's free response, I don't want you to go any further. Just stop. Just stop when you have the answer. All right, let's look at another one. This was C. I have the inverse of cosine of 5 pi fourths. Who says that the answer has to be 5 pi fourths? It's not. And the reason is because of the limitations of an inverse. In fact, what piece, if I draw my inverse, let's go, actually, let's draw our function. So it should look something like this. what piece is going to be saved? Yeah, only the piece from -1 to 1. So from negative, so from -1 to 1. And so we're going to reverse that. And so what are my values from -1 to 1 for, let's see, let's look at it a different way. Let's look at our unit circle. When cosine, which is our x value, goes from -1 to 1, what piece is from -1 to 1? What piece for a cosine is from -1 to 1? Well, this is my 1, and this is my -1. So that means we're looking at this piece here, that rotation, which would be from 0, what is that, 0 to 0 to pi, right? 0 to pi, so it'd be this little piece there. So so I need to replicate this piece right here. So that would be something like, can I do this? Something like that. I don't know if I reflected it right. Doesn't feel like I reflected it right. Doesn't look like that. All right, well, I guess we can go to Desmos. So we have cosine of x and compare that to the inverse of x. Yeah, that's that piece there. All right, so I have, what quadrant am I in for here? I'm in the third quadrant. So if I do my unit circle here, we're going to divide this up into 1, 2, 3, 4, and then 5. So yeah, we're going to traverse through 1 pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths, 5 pi fourths. Now that's outside. If I do 5 pi fourths, what does that give me right here? What is that x value? Well, it's the same as the x value over here, except for it's negative. What is the x value here? Yeah, that's the square root of 2 over 2, which means this over here is what? Negative the square root of 2 over 2. Good. Now let's consider, so now I have the inverse of cosine of the square root of 2 over 2. Negative the square root of 2 over 2. Now the problem is that that's outside, actually all of it's outside of it. Let's see. Negative the square root of 2 over 2, which would also give me this piece right here, right? So this would have to, this is also going to give me the negative the square root of 2 over 2, correct? So what is this rotation here within our domain, the domain of the inverse? Louder? Yeah, that's going to give us 3 pi fourths. The answer to all this is 3 pi fourths. Emerson, are you confused?
Yes.
Okay. So what I did is I first found what cosine of 5 pi fourths was, right? What did I find?
Negative square root of 2.
Did that part make sense?
Yes.
Okay. Now, the problem is that for an inverse, we're limited because otherwise we don't have a function, right? If this just repeated itself over and over again, then it violates the vertical line test. So for an inverse, we only have a piece of this function that doesn't allow us to violate the vertical line test. So we see that the inverse is just going to give us that the inverse is just traversing through the first and second quadrant. In fact, we can see that here. And so from what we have here, we're limited to a square root, a square root of 2 over 2, or a negative square root. Excuse me, we're limited to a negative square root of 2 over 2 for a value within the range of our, or in the interval of our domain. Well, I have a negative square root of 2 over 2 in the second quadrant. So I'm looking at that rotation there. Yeah, the answer is 3/4. You're still confused? Okay. Let me try to think of another one that's going to be confusing like that.
Since you're saying that you want to get a negative square root of 2 over 2, why is it that you chose the one that means 3/4 and not 5/4? Because I remember saying that something about
Yeah. Okay, let's go back. Let's do the whole problem over again. So I have the inverse of cosine of 5/4. Now it seems because these are inverses that the answer should just be 5/4 because these should just eliminate. Well,
Just realize how it works.
you're good?
Yes.
So does anybody else want me to continue?
Go for it.
Okay. So what I'm going to look at what this piece right here is. That's going to put me in the fourth quadrant. I'm going to take pi and divide it up into units, into 4 different units. So that's going to give me this here, and it looks like I'm even going further. So I'm rotating 1/4, 2/4, 3/4, 4/4, 5/4. This is where I end. Now, what's really cool is that this triangle here is congruent to this triangle here. So let's figure out what the rotation here is to figure out what our x value is here, which is similar to the one down here. So I'm going to use, for this rotation here, I'm going to use 5/4. What is cosine of 5/4? It is the square root of 2 over 2. It's the square root of 2 over 2. But how is that different than this unit down here? Yeah, because you're going into the x, the negative x value, into the negatives there. So that's going to give me negative the square root of 2 over 2. So because now I have to, so what I have, if I'm replacing all this with negative the square root of 2 over 2, what I have then is the cosine, or the inverse of cosine of negative the square root of 2 over 2. That's what I have. That's what I'm trying to figure out now. Correct? Now, the inverse is going to be restricted because it's not going to be a function if it's not restricted. Because the inverse of a periodic function that looks like this is something like this, which is not a function. So I'm going to limit the amount of my domain. What part is going to be limited? Well, when we look at when we look at an when we look at an inverse, the domain becomes the range and the range becomes the domain. The x becomes the y becomes the x. And so since the range of my function is from -1 to 1, then that's the range. Then for my inverse, that should become the domain. So we're going to try to find where we go from -1, when x is -1, we're going to rotate from when x is -1 to 1, because that's we're taking our range and turning it into the domain. Well, I think it's easier to think of this with our unit circle. And when I look at my unit circle, where x is 1, we're over here. And when x is -1, we're over here. Now, if it's a positive rotation, then that should be this rotation here. From 0 to pi. So if we're rotating from 0 to pi, then that's going to be our range. Our range is from 0 to pi. So we're going to go from 0 to wherever pi is up here, pi. Here's an easier way to think of it. Just go with whatever the shortest rotation is. If there's 2 rotations, then go with, if 2 rotations are the same distance, then go with the positive rotation. So if I look at something, let's go back up to here. Let's see, let's wrap our heads around what I'm trying to say. Where was I down here? Okay, so we have a negative, because of our limitation. We always start here at our initial side here. We found that we have our x value is negative the square root of 2 over 2 in 2 locations. Here, the negative square root of 2 over 2, and down here. From our initial side, what's the closest rotation? Right here. So just go with that one. That's the easier way to think of it, is just go with whatever the shortest rotation is. What if you end up with 2 that are the same? What if I end up with something, oh, actually here that we have this rotation here, right? That's the same rotation, the same distance. So go with the positive rotation. Let me try to do another one that will help wrap our heads around. So we go with this right here, which is 3 pi. 3 pi, was it 3 pi? 3 pi fourths? 3 pi fourths? 3 pi fourths. Let's try to think of a sine one. Sine. Let's think of a sine one. Sine. The inverse of sine of 3 pi fourths. What is this? Yeah. Yeah, we're rotating 1, 2, 3. We're here. What's my y value at that point? It's the same as the y value here. And so we're using our sine of pi fourths, which is going to be the square root of 2 over 2. So this value here is the square root of 2 over 2. And this, why is this the same, the square root of 2 over 2? Yeah. And so all of this is the square root of 2 over 2. What is this? At this point, my calculator doesn't know that I rotated over here. So yeah, my calculator is just going to go with the shortest. So my calculator is going to say pi fourths is my answer here. Does that make sense? Just go with the shortest rotation. If 2 are equal, then go with the positive. Want to do another one?
What is sine algebraic if we were to write it out?
If I was writing out sine?
Yeah, if we were to write it out and then we were to take that graph.
And graph. So if I have y equals sine of, so
What's that function?
sine of x. What is that function graphically?
Well, yeah, I know what it is graphically, but if we were to write it out, how is it then?
I'm not sure what you mean by writing it out.
Like if I wanted to find the derivative of sine.
We haven't done any calculus yet. But none of this is calculus.
I know.
All of this is trigonometry so far. We're about to do calculus. In fact, we're running out of time, so we have to do the calculus soon. So trigonometry is literally the science of triangles. And so it's hard to think of trigonometry entirely algebraically when it's dependent on triangles. And so what is this algebraically? Well, we did it algebraically here. We found the answer algebraically here. We found out what goes on, you know, and we're still thinking of a physical place, but, you know, that's why we have to use our hand and stuff. Oh, here's a question then. What is sine of a not special angle? Like sine of, I don't know, pi sevenths. We cannot do this without a calculator. We are dependent on a calculator. So the only angles we can do are special angles. All of the other ones, somebody painstakingly measured all of those angles for us and they put them into a table. When I was your age, I had to look in the back of our geometry book to find the table to interpret what those trigonometric ratios were. But all those tables were put into your calculator. So we can calculate this only because it's in a calculator or in a table. You can't do this algebraically. Okay, we need to move on to the calculus. Same with logarithms. Same with logarithms, unless it's something basic like, you know, log base 3 of 3, which is 1, or log base 3 of 9, which is log base 3 of 3 squared, which would be 2. We can't figure out log base 3 of 2 without a calculator, because these were also made into tables by mathematicians for us. Okay, moving on. Now we need to move on to the trigonometry. This is really the important part, and I know we don't have a lot of time left, so please pay attention. Sasha, I think it's time for you to leave. Okay. Please watch the rest of the video, Sasha, because this is the important part. So trig derivatives. Now these are also, we need to make these into flashcards. These are, in fact, we have 6. There's 6 of these that you will have to memorize. So make these into flashcards. Now let's consider if we had y equals sine of x. I'm going to go steal this from our graph here, just to make my life easier. I'm going to just say y equals sine of x. So I get something like this graph. This graph here. Now, if you're given the graph and you have to find the derivative graph, how do you do it? What was the first step? Find the zero slope, right? So here I have a zero slope, so I'm going to mark it here. Here I have a zero slope, it's here. Here I have a zero slope, it's here. And here I have a zero slope, so I have a point there for my derivative graph. Describe to me the slope from these two zero slopes there. What is happening with this slope? It's negative. Can you describe the steepness over time? It hits the steepest part at the inflection point and then starts to flatten out. Yeah. So it's all negative. So the derivative function should all be below the x-axis. So it should look something like this. What about this piece here for our red graph? Describe the slope. It's positive, and I see that it starts to get gradually steeper and steeper until we reach a maximum at the inflection point, and then it becomes less steep. It's all positive, so it should be, the derivative function should all be above the x-axis, showing that it's positive. So we have something like this. What about this piece here? Describe the slope. It's also positive, so I'm going to draw something that looks more or less like this. Can you describe the equation for the blue graph? It's cosine. The derivative of sine is cosine.
Is it impossible to do this in there?
What's that?
Is it impossible to do this in American?
Showing this step.
We did it here with the graph.
Showing how it'd go from one to the next.
Yeah.
Ooh. I'm not sure how you do it.
Use the power move or whatever.
You cannot use the power rule. These are ones you have to memorize. You have to make flashcards out of these. Make sure you memorize these. All right, here's another one. Let's do cosine. Gosh. Okay, here's the next one. We're going to do the same thing. What is the rule when we try to find the derivative function graphically? We find all the zero slopes. There's a zero slope here, so I'm going to mark it here. There's a zero slope here. I'm going to mark it there. Zero slope here. I'm going to mark it here. Describe to me the slope for the red graph from here to here. It's positive. I'm going to show that then by drawing my graph like this. It's all positive. It's all above the x-axis. What about the slope from this zero slope to this zero slope? It's negative. It's all negative, which means it has to be below the x-axis. So that would be this value here. And what about this piece? What about the slope here for the red graph? It's all positive, so that the derivative function should all be above the x-axis. I should end up with something like this. Now I want you to consider transformations. If you consider transformations, what does the blue graph have to be? Negative sine of x, yep. Do you see that it's just a flip? Look at the red graph here versus the blue graph here. Look at the red graph at the top versus the blue graph at the bottom. Do you see that it's just a vertical flip? So the derivative of sine of x is what? Cosine of x. The derivative of cosine is negative sine of x. Correct. Okay, let's do tangent. Wait. You good? Mr. Hall, I wasn't talking to you. Okay. What about y equals tangent of x? Well, we do know something about tangent of x. We know an identity for that. Yeah, we know that this is sine of x over cosine of x. How would you take the derivative of this? Don't we? There's a special rule that we have to follow if we have a function over a function. It's the quotient rule. Low, low, low d high. Nice. So when we take the derivative of this, we have low d high. The derivative of sine is what? Cosine of x. So low d high minus high d low. What's the derivative of cosine? Yeah, negative sine of x over low. Cosine squared of x. Does that look good? Is there any way to clean this up? What's cosine of x times cosine of x? Cosine squared of x. What's negative times a negative? A positive. What's sine of x times sine of x? Sine squared of x over cosine squared of x, okay? Yeah, this is one of our identities. That's one. That's our Pythagorean identity. So we're left with y prime equals 1 over cosine squared of x. Is there any other way to clean this up at all? Is there a, I don't know, a reciprocal identity that we could use? Nice. There you go. The derivative of tangent of x is secant squared of x. That's another one you have to memorize. Make a flashcard. We have to memorize sine of x. Derivative is cosine of x. Derivative of cosine of x is negative sine of x. The derivative of tangent of x is secant squared of x. Now, the other ones are going to be fairly easy to remember. In fact, let's just make a chart of all these. Yeah, Riley, I'm sorry I can't make it easier for you. We literally have to have these memorized. There's not a shortcut. Okay, so the function.
I mean, doing it algebraically, but not the short.
Yeah. Oh, I know what you're talking. This is what I think you're talking about. The limit as h approaches 0 of if our function is y equals sine of x, then this becomes sine of x plus h minus sine of x over h.
Right, and I was thinking like, what if you were to write out sine of x?
It's just going to be so much more messy. So
all of this graph.
Was it?
So they found this all graph.
That's how we teach it. Whether that was found graphically or not is another matter. I don't know how they found it. That's an interesting question of the history of how this was discovered. So the derivative of sine of x is cosine of x. You need to have this memorized. These are flashcards. Y equals cosine of x is, the derivative is negative sine of x. The derivative of tangent of x. Secant squared of x. You need to have these memorized. Okay, what if we use the reciprocal properties? You have to have these memorized too. How many new flashcards did I say today? 6. So we have 3 more. So we're going to do the reciprocal of all of these. What's the reciprocal of tangent of x? Cotangent of x. That's going to be y prime, this is the derivative, is negative cosecant squared of x. We can go through the same steps by knowing that cotangent is cosine of x over sine of x, and do the same thing to show that it's the same. But it's easy, this should be fairly easy to remember, because when we do the reciprocal, well, it turns out that, instead of secant, we have cosecant. And then instead of positive, it's negative. So it's sort of, I don't know, it seems a little convenient that these are turning out to be a little bit easier to memorize than maybe they could have been. All right, secant of x, this is one of our harder ones. Secant of x, the derivative of secant of x is secant of x times tangent of x. These you have to have memorized. If you want to see the proof of that, we're running out of time. I don't have time to show you the proof of it. You can Google it, but I would say just write it as y equals 1 over cosine of x, and then do the quotient property. if we do the quotient rule, then that would allow us to see that we get this. Okay, so we have secant and then we have cosecant. Cosecant of x. And this becomes, the derivative of this is negative cosecant of x times cotangent of x. These are, all of these you have to memorize. I guess you can recreate some of these on when you're taking the test, but that's going to eat up time. So have them memorized. Okay, let's do an example. I want to find dy dx of y equals x squared times sine of x.
Times cosine.
So do you see, when you look at this, do you see a function times another function? Which means we have to use what? We have to use the product rule. So if we have to use the product rule, what does this become? Louder? Is that Emerson? Somebody said, is it? Finish.
I guess it's is it x squared plus times cosine of x plus 2x times sine of x.
Yep. Easy peasy. If this is free response, just stop. Actually, I'm not sure if you can really clean that one up that much more anyway. Okay, another one. Maybe this is the last one. Actually, I think this is the last one. I want the same directions. I want to find the derivative of cosine of x over 1 minus sine of x. Louder. I heard somebody say, isn't it? Do we just take the derivative of the top over the derivative of the bottom? No, why not? This is a function divided by a function. That's the quotient rule. Say the quotient rule. What is the quotient rule? Say it louder. Okay, low, D high. Louder. Minus high. What's the derivative of this?
I wasn't talking to you, I'm sorry. But that is actually.
What's the derivative of a constant? 0. So we're just taking the derivative of this piece. What's the derivative of negative sine of x? Yeah, it's negative cosine of x over low, low.
Is it 1 minus sine of x?
Is this 1 minus sine of x, or is this 1 minus sine of x times 1 minus sine of x? This is not a difference of squares.
Yeah, wouldn't it, I thought that just 1 minus sine of x alone is cosine of x.
1 minus
Cosine of x.
sine squared of x.
Oh, sine squared. Oh.
Okay. Now what can I do with the numerator? Well, it looks like I can distribute this mess here. That gives me what? Negative sine of x plus sine squared of x plus cosine squared of x all over 1 minus sine of x times 1 minus sine of x. What does this become? 1. So that gives me 1 minus sine of x over 1 minus sine of x times 1 minus sine of x. Louder? You can cancel 1. What's in the numerator right now? 1. So I have 1 over 1 minus sine of x. Yes, that is simplified enough. If it's free response, I want you to stop here.